All right, so good morning, everybody. How are we doing the last day of VS Live? So last night was the party, right? Dave and Buster's. So everybody's going to be kind of a little bit sleepy, all gamed out. So I'll try to speak loud. All right. VS Live is one of my favorite conferences. I like it. Everybody's usually super engaged. It's an old conference, too. It's 30 years old, I just found out the other day. So that's pretty amazing that it's keeping it going. I also love it when it's in the Redmond region. That means I get to go home and sleep in my own bed instead of getting a hotel, which is pretty awesome too. All right, so my name is Matt Sokup. I work in cloud advocacy here at Microsoft, which means a lot of times I get to build samples, do conferences, blogs, videos. So I really like my job. And if you ever need to get in contact with me, another part of my job is to help developers out to make the developer experience on all our products better, whether it's just helping out with documentation or making sure that we get funnel the feedback back to the product team. We want to make your experience using our products, Visual Studio, .NET, anything, Azure, better. So get a hold of me at either msokup or CodeMailMatting on Twitter or matt.sokup@microsoft.com. Did I say Twitter? I meant LinkedIn. I didn't put a Twitter up because I hardly ever go there anymore. And so I was like, when I was putting this slide together, it's like, I'm not sure where I should put social up anymore. So it's like, do I put Mastodon? Do I put the new Instagram? Threads? I don't know. So LinkedIn, GitHub, email, I try to monitor them all. So except for Twitter, I guess. I don't really go to Twitter that much anymore. So anyways, we're going to talk about Azure and building .NET apps on Azure. And I did an initial portion of this talk for .NET Conf. And .NET Conf, we only had 20 minutes to do everything. And so that's where the Whirlwind came from. Now we have 75 minutes to really expand it out and make it to talk about a whole lot of stuff. And so, which is actually super nice. When I was practicing this talk earlier this week, I thought, wow, we can really go into it. So if you have any questions at all, please feel free to ask. And I will also, when I find anything interesting that I want to talk about, I'm going to dive into that too. So another talk I've been doing recently is called the Reliable Web Apps Talk. And what that's all about is taking a web application on-prem or a virtual machine, bringing it up to Azure and making sure that it doesn't that it runs in the cloud and it doesn't crash, and it's minimal changes to your code that you can get it up and running on Azure. So I'll be talking about some patterns that come from that as well as we go through. So yeah, what we're going to do is, a lot of people are probably familiar with already like App Service, Azure SQL, Blob Storage, and CDN. So we'll spend some time though talking about those as well and bringing your .NET apps to those. And what's cool about that, there's going to be minimal changes that we have to do to get our apps up and running with those. And so on-prem, you might be using those already. We'll talk about some tips and tricks we can do to make running those better. But most of the time, we can bring our apps there and be good to go. The Whirlwind, though, is when we start talking about the other services that I have over on the right-hand side. Managed identity, which is pretty cool to get your applications talking to each other via Active Directory, so we can really narrow down the permissions each of them have. Or Azure Functions, serverless. Azure SignalR, real-time, and so on down the line. And we'll close it out talking about the Azure Developer CLI, which is really a really neat tool that you can get your applications up on Azure easily in a way that anybody can repeat on your team. And also I see that Savannah, she's the PM on the team. She's coming to give a talk just on the Azure Developer CLI later today on it, just a half-hour talk, which is, I encourage you all to attend because it's a super cool tool. And you can put it into your DevOps pipeline too. So have it running locally, get it up onto either Azure DevOps or GitHub Actions, and you know it's going to run in the cloud too. All right, we're going to start off though with App Service, Azure SQL, then move over into the other services. All right, and so this is what we're going to build. It's going to be a pizza Lots of matzah, yeah. Pizza online ordering application. And I'll jump off to it right now, but yeah, so the idea behind this is that there's not too much to it because I wanted to keep it relatively simple so we can talk about the Azure services behind it. And let's actually look at it right now. So I will bring it off to here. Yeah, and what's cool, I'm running a Mac, but so every now and then you'll see me jump up to here, you'll see the remote desktop. I'm actually running on a dev box. So if you all saw Amanda's keynote on Tuesday, she probably talked about dev boxes. So they work great, actually way faster than my Mac. So anyways, these are all the Azure services that I have here that we're going to get into. So there's quite a few involved that just run this simple application. So a list coming from Azure SQL of a menu items of pizza. So we go over to the lots of matzah. We see it. We can add it to the order. There it is in our order. We can place the order, and then it starts waiting for transmission. Where is my exact order? And let me go over to Azure Functions, get the URL up. My function app. Copy it. Paste it in, API, Swagger UI. All right, so that should bring that up. It's just some Swagger tooling. And we'll talk about this too, how to get Swagger into Azure Functions. And then all it is, you can see it's waiting for a transmission. And I'll put the order ID in, which happens to be, come on, make this bigger because I can't see it, 54. Yeah, I'm going to respond to it. Yeah, it's super simple. Doing signal R, so it goes right away. So just 1, 2, and it goes on through. And yeah, it's super fast. But the thing is, when I was playing around with it this morning, I realized that it stops at the delivery. It never actually gets delivered. So you can never actually trust the delivery service. Yeah. So it's not quite there. But yeah, I must have known subconsciously when I was developing it that we never actually get our pizza. But yeah, so there it is. So we're getting from Azure Functions over back to our app using a SignalR, which is actually kind of cool that it's a persistent connection, but with a serverless application. The serverless is supposed to go away, thus the serverless. Yes. Using a connection string, and I'll show you how we could go into actually using both managed identity and user authentication through Active Directory. But here for demo purposes, I just went straight connection strings and doing it that way. So the question was, did we use SignalR with authentication? And the answer is for demonstrations and quick development, no. But once we get to the SignalR portion, I'll point out where we could pop that in. When you say a key, right. So you're talking like a connection string key? Yeah, we do. I do show that. Yeah. So once we get to SignalR, we'll talk a little bit about auth and how to get your SignalR talking to both your apps and actually how to get Blazor using SignalR too. So the web application itself is a Blazor server application rather than a WASM app. But there is, if you were doing WASM, the differences would be minimal, mainly just it running on the browser rather than running it on the server. Otherwise, really nothing. Okay. That's what we're going to be building. Here's what it looks like right now. Browser comes in, talks to the Blazor server, Blazor server then talks to two minimal web APIs. One does the checkout process, and goes in and gets to actually Azure serverless, Azure SQL serverless, which is kind of neat. We have a SQL database that can go away when you're not using it, which means cheaper. That's the best thing I like about serverless. Goes away. Also a menu web API. So two APIs that just do one thing, kind of best practices when you're building up microservice architecture. Spin them down to only doing one thing at a time for your microservices. Also, we're going through a blob storage for those images, and we threw a CDN in front of it to get things out quicker. So I showed off Signal R in the demo. That's the finished demo. We're going to get there. Here, the first part, we don't have Signal R a part of it. So just pretend you didn't see the delivery person get stuck in traffic yet. Question? The data stays there. So the data, there's going to be persistent storage there. So the question is, what does SQL serverless mean? So SQL serverless means that the server itself that listening for connections stops. So you still have persistent storage there. So the hard drive essentially stays around, but the CPU scales down to 0 and goes away. So you're not paying for the CPU to keep on running when you're not actually using it any longer. And it's the same thing for Azure Functions. When you think about it, you still have your code deployed to Azure Functions. You still have DLLs out there that sit with Azure Functions, just that the CPU goes down to 0. So, but SQL Server, obviously you hope that you have a larger database and more storage behind it. All right, so Azure App Service gives you a bunch of different things. Obviously, at its heart, it's a web server, right? It's IIS, really, Internet Information Server. It's a platform as a service, as we like to call in a cloud world. And there's a bunch of different as a services that we always talk about, cloud world regardless, not even Azure. And so the way they go is you have infrastructure as a service, and you go up to platform as a service, and then you start going out to various as a services, whether it's functions as a service or identity as a service or really anything you can start calling as a service. And what infrastructure as a service is, you can think of it kind of as like virtual machines or storage, and you're doing most of the work yourself. Like you're going to take on the updates and such. So infrastructure or storage, not so much, but virtual machines, you're taking on everything. Like you're going to keep the operating system up to date and so on. Platform as a service kind of abstracts it away. You're saying, oh, hey, cloud vendor, you take on a lot of this work for me. And so it's going to take on like scaling rules. It's going to take on like give you monitoring and so on. So it's just one step up. And that's what platform as a service means. But at the same time, it's only giving you web. So it's focusing in on what it does, which is good. So Azure App Service runs both. You can run a Windows flavor of it and a Linux flavor of it, if that's what you wanted to do. And you can also deploy containers to it. So if you have your containerized architecture, you can deploy right to a Linux container on App Service, and away you go. Here, what I'm doing, I just right-click deployed a Windows application to it. If I wanted to do a .NET Framework app, a 4.x application, I could do that as well. I don't have to be running like .NET 6 or .NET 7 to use App Service. So that's actually a nice thing when we talk about the reliable web apps. With a minimal, essentially a lift and shift, if you're running .NET Framework on-premise, you can get up to the cloud without having to do a ton of work. Actually, you don't have to do really any work to get it up. Question? Unless you're using Windows Kerberos authentication. Yes. All right. So the question was, how much authentication, how much work do you have to do to get a .NET Framework app from on-prem to app service to the cloud. Yes. If you're actually hooking in with some Active Directory specific things that are only available on premise, yes, you are going to have to do some work. So yeah, I oversimplified. Yes, yeah. And so that's actually a good point. When you're moving from on-prem over to the cloud, you are going to have to sit down and think, what do I want to do and how much cost do I want to incur when I do it? You know, so can I just get my stuff up there, or do I want to take the cost of re-architecting some of the application itself and making it more future-proof, so to speak? So the idea is, though, if you can get it up there as is and not have to take on that extra cost, maybe you don't need to, right? And then I work for Microsoft, and I'm telling you, like, you don't have to. Might be a good idea. It might be a good idea, but you don't have to. So, and App Service also gives you a ton of scaling rules, which we'll take a peek at in a second. Monitoring hooks in with Application Insights, which is now kind of called Azure Monitoring. And so you can actually dig in to see where errors are occurring and so on. So actually right down to the line number of your code. So Azure SQL Database, it's a good old relational database that we all know and love. But I think Davide's after this, he has a talk yet today, it also supports NoSQL columns and also graph columns. So essentially, like kind of like Facebook is built off of graph databases, like, you know, this friend likes that person and so on. So you can kind of suggest people. It's a graph is weird, but it supports it. So which is nice. I mean, so SQL I always thought of as pure relational, but it's evolving, and it's all can be in an Azure SQL database. Also gives you monitoring. So I always like to think of Azure SQL Database as another platform as a service. You can also call it data as a service, but it's more of a platform as a service. It's above where you're managing everything yourself. You're letting the cloud provider manage it for you. We talked about that it can scale to 0. Where CPU is scaling to 0, you still have data around for it. And what's neat, and I'll show you how to do this, is you do get passwordless connections to it. And this comes through both the Entity Framework, as long as you're using the Azure SDK with it. And this works for both, well, actually Azure SQL and Redis and SQL, or PostgreSQL and PostgreSQL. And so what's neat about that is now we don't have to actually use a connection string at all to authenticate your web app, or even on-prem, you developing to Azure SQL. So that's nice. You don't have to have the connection strings lying around and accidentally leak something. And it has some cool portal features that I always like when developing. I know a lot of people don't have access to the portal all the time when they're developing, but I find it's kind of neat that you're able to issue SQL queries, do data modifications right from the portal. It's relatively new. I think it's still in preview, but it's nice to have at your disposal should you need it. Azure Storage. First thing that I always think of with Azure Storage is blob storage. Here we're talking images, or if you had PDF files or whatever, you can throw it in there. It's, you know, binary large object. Not sure what the B stands for, but it's huge files that you want to put in there, or small files, and a lot of them. But it also, your Azure Storage also has queues that you can put into, so messaging. Tables, key value stores, and this is a very underrated portion of Azure Storage. So if you find yourself that you just need key values, maybe you don't need to go with a full-on database. You can use maybe Azure Storage for that. And the values can be strings, right? So you can serialize your JSON objects down to a string and pop that into a table storage. And that's why it's cheap. Azure Storage itself is considerably less expensive than using SQL or Cosmos or something like that. So give that a thought if you're doing something. If you can get away with doing table storage rather than a full-on database, might be worth it. And finally, Azure CDN, Content Delivery Network. And so the idea of this is that you're getting data to live out on the edge. And so that's the cache static data on the edge. And the edge meaning different Azure nodes around the world. So in our example is that we're delivering the pizza images to people no matter where they live around the world quickly. And it's just near them, right? So they don't have to, because it's static, we know that data is not going to change. They can download it super quickly. And it can actually live fairly easily on top of blob storage. Essentially, all you're doing is you're creating an endpoint, and then you're just pointing it back to the blob storage that you want to have live on the edge. And it's used to serve data faster. And the best part is, as developers, we don't care, other than changing the URL that our data points to. Otherwise, completely seamless otherwise. If we're uploading data, we're going to blob storage. If we're serving data, we're going to use it from the CDN. Question? Does it have DDoS protection? We'll talk about that. Yeah, you're asking all the good questions. All right, so let's take a peek at various things here. All righty, so the first thing I want to take a peek at is, we'll jump on into the Azure portal. I'll bring this up to full view. And again, I have the resource group open that has everything in it. The first thing you mentioned is, does the content delivery network have DDoS protection? And what you're going to want to do, so there's two different types of content delivery networks you can go with. There's the one that I was talking about, which is the basic profile. Then there's another one you can put behind Azure Front Door, which has a whole lot of web application firewall rules to it. That's going to have your DDoS protection. So that's like CDN++. So that's where you're going to want to go with it. And you can see right here, it does say Front Door plus CDN profile. So that's like your newest one. And that's where you're going to want to go with it. So we'll talk a little bit about the CDN first. So I just jumped into the CDN profile. And actually, let's jump into storage so I can show you how it's served out. So here's my Azure storage account. What's neat about this, I do have a storage browser that I can jump into, and I can see my various services. But there's also file shares in there, but normally we're going to use queues or tables, and we're using blob containers here. And I can just see images. I put them all in a media folder just because that's the way I did things. Here you can organize things the way you want. And I can jump in, see the URL that this would be at, or I can just go in and click. Oh, that's where we just were. You edit it, and I can see what it looks like at that point. So I can actually do some editing from within the portal itself, rather than actually having to do everything through code. But let's say I mentioned that you can put a CDN in front of it fairly easily. And so just by typing CDN over here, you get that Front Door plus CDN profiles. And then what we can do is, I already have one new here, but we can new one up. And here's where you can new up a Front Door or the, I'll call it the legacy Azure CDN, although there's nothing wrong with it. And then just start saying, you know what, my origin host name, this is where I want it to come from. This is where I want the CDN to wrap, and this is what I want to actually put out on the edge. And then once I start going through things, I can start saying which blob container I want it to push out. And to answer the question about more security, it's right here, the Front Door Premium Security Optimized, where you have your web application rules as well. But I already have one, and let's jump out to that. And it's fairly easy. We have an endpoint host name, so this is where now we would access our images from, wrapping the origin host name, and I'll copy that. I'll just paste it in, and it's media / I know there's a pizza1.jpg. There's a pizza JPEG too. Delicious. It's not even a cartoon image. So yeah, it serves that from the edge. It's pulling it from Azure storage, but it's not, make that larger. It's CDNE rather than my Azure storage URL, which would be STQD. Now, why are all these names weird? We'll talk about that later. It's mainly because I can deploy it and know that I'm not going to overlap with anything. So, and actually let's do that real quick. So if I put the storage name in, images /media /pizza.jpg, brings up the same thing. So the CDN just wraps it over, and I have the CDN pointing at the images blob container, which is why I don't have to specify that, but I still have to specify the media folder. Cool. And then in my code, let's take a peek at the code real quick. It's a fairly simple .NET application. I have the Blazor server right here, and then the 2 API applications to it. And what one of the API applications do, the more interesting one is the menu one. The menu one has Entity Framework Core, which does, on the first load, it initializes the database, just pops in 4 pizzas for me. It also initializes the storage when we first go through. So on the program load, it calls out to the upload images, which just right here uses the blob container client to go through, loads up everything I have in my media folder here, and uploads it. So I just put this media folder as a convenience method to have all of my images there, so I can just upload them at the beginning. Whether you're going to do this or not in production, probably not. You're probably going to have it all done for you, but that's what I'm doing here. Now to actually display things, over in the pizza details.razor file, I'm just using image URL. And then I just have to make sure in my config file, I specify the right URL. So here I'm saying STQD, so ST here meaning storage. And so if I run it locally, I'll be pulling it from Azure Storage. But if I change it around and point it to the CDN, it would pull this exact same thing. So when I'm developing, as long as I have the image correct or the URL correct, it's completely seamless to me. So that, and we should be loaded up. Lots of Matza pulls that. I delete them, and then grabbing the CDN again. And then popping that into here. Should be seamless, assuming I didn't need a ending slash. Yeah, so it just works. Cool. All right, so I wanted to show off a little bit about what we get in the portal for like SQL, Azure SQL. I have two SQL databases all underneath the same Azure SQL Server. Azure SQL Server itself is kind of neat in that I can set IP firewall rules. Underneath network. So right now, I only have one firewall rule in effect, and this is my home IP address. It's not the IP address I'm running now, but I have allow Azure services and resources to access the server. So when I run locally on this dev box, I can access it. So I'm kind of cut off from the world, which is neat. And that's the way you should be having it, at least in production, is cut off from the world entirely. So I should really take my allowed off the connectivity and run this, just allow Azure services to get at my SQL. So that's the SQL Server. Inside the SQL Server, as I mentioned, I have two databases in here, and the databases are kind of neat. In that one, I have my user account blocked, so I can't actually get to it. I'm going to have to actually use SQL Server authentication. In real life, you'll probably want to do Active Directory authentication, but I just wanted to show that you can partition it off from one to the other. And so I will look up what my my password is. And it's going to be. So this is the best part. This talk is being recorded, so I'm going to have to make sure I shut everything down. That is it. Paste it in. And so here I have a full-blown SQL editor that I could go through and see. Oh, I'm in the wrong one. So pizzas actually gets deleted after. This is my order table. I wipe it out after everything, just the way I developed it. But if I go into other database, the one for the menu, query editor, back into it. You can see I actually have data there. For some reason, I called both tables pizzas, which was very ingenious of me. But there they are. Cool. And I could change it as well by if I wanted to do an update statement and everything. Alrighty, so what else did I want to show real quickly through the portal? But the first couple was, oh, come on, scaling rules. And I'm going to jump out to a different app to do it because my scaling rules on my app services, I cannot show because I was a little bit cheap. And, but this is actually a good point. So you can only scale when you have a certain SKU installed. And so I have the basic SKU installed here. And so I can't actually do any rules-based scaling. It's just the way things are. But one point here that I wanted to mention as a best practice is when you do set up scaling for your applications in the real world, scale out before you scale up. It's just, it works better and works faster. So when you have a choice, instead of scaling up when kind of going to a different hardware set, that's going to take your application down. But when you scale out, adding more to it, you're going to keep your application up, and then another server essentially comes online and nothing goes down. So let's quickly take a look at some of the rules that we can do. This is a whole other resource group, but now I can look at the scaling. what I have this. I also have this one too, cheap, basic, very, very. I'll update this one. We'll come back to it a little bit later. I'm all about saving the money I get. All right. All right, let's go to rule space. It is there. And so if I wanted to do scaling, what I can set up are things such as scaling on a metric. So I can say, add a scale condition to it, and I can say based on a particular time to a scale higher or scale lower. I could also do, if I get a certain scale condition, such as my CPU goes over a certain amount, I can automatically scale to more instances and so on. So that's kind of nice as well. So it's something I was talking about before with where the app surface gives you built-in scaling. And the last thing I wanted to mention before we move on outside of the built-in, or the more basic ones, that is the monitoring. And I know this one should give me some information, hopefully. Good. And so what I can do is I can go through things and actually view such like a fail request or server response time. And I like looking at the fail requests because then, right now I'm just getting a bunch of 404s, which aren't very interesting, but it can at least tell me what's giving me my 404. And in this case, I can see the URL, which actually is a basic URL that's bombing out on me. But if I had something that was a little more interesting, I could go through, see it, create a work item based off of it to debug it, and so on. So, which is nice. And as you saw here, I can actually create a whole dashboard off of it as well. And view everything going on at one go. Yep. What kind of question was, can I fire events based on rules? Now, what kind of events are we talking about? Yes, I could set up with event grid. And so I can have event grid start looking for certain events coming from various servers. And then it takes action based on that. So I could like say my app service got over 85%. I can then have it like send an email or fire up an Azure function or do whatever. So it's kind of like event grid is kind of like your orchestration. You know, it's a high way of thinking about it. So it could do a ton, just a ton more too. Yep. And you could do that event grid is huge. You can have like Azure Monitor do that too if that's what you wanted, if that's all you're interested in. Alrighty, so let's go back to the slides. All right, so real time, Azure Signal R is the ability to add real time functionality. And so what's nice about that is no need to pull the server from your website or your web or your mobile application. You don't actually have to say, hey, give me an update, pull down on if you're doing a mobile app, it's going to come to you, which is nice. It's based off of standards, web-based or SSE or long polling. WebSockets is the default and what it wants to do, but will fall back and keep on working if you need it to do it. There is ASP.NET Core support built in natively, so which is nice because when we move up to Azure, it just works again. ASP.NET Core has SignalR built into it as well. So like Azure SignalR is kind of like the super version of it. It gives you a ton of scaling, like it's meant for your large scale deployments. So the guidance that the ASP.NET team says is that you're going to deploy a Blazor server app, move it over to Azure SignalR because you want it to keep on running. So Blazor uses SignalR. It's really the SignalR library is the same one that's bundled in to ASP.NET Core. There's a little bit of changes that we have to do in order to get our Blazor server running to use it. And it uses the SignalR for real-time updates. And it's, like I said, it's recommended to go to do that. Oh, and one thing that you want to do, and I'll show this in the code, is that we want to enable sticky sessions when we go from Blazor to ASP.NET Core SignalR to Blazor SignalR, so we're communicating to the same hub. All right, so let's see it. Blazor and Azure SignalR at the same time. One of the things I like best about Azure SignalR is the way to set it up within Azure is very simple. There's not a whole lot to it. Let's redo this. You'll see that I have two SignalR servers set up, one for Blazor, one for functions. That is because the one thing that we do have to decide when we are setting up SignalR is where is it? Whether it should be a standard or a serverless SignalR. So when we were using serverless before, it's getting used to having serverless connections to it, that the connections might go away. But standard is the ASP.NET SignalR that we're used to. So that's the main difference. That's really the only decision you have to make when you're setting it up. Otherwise, it's going to be the same deal. And I think the question you had before is whether we're using keys for connecting to SignalR. Here's where we're doing it. We're getting the keys based off of it. And all we're doing then is popping it into our client side. We could use Azure AD. And I'll talk about that a little bit more, how we would do that. And here you would actually need a client secret that you would generate within Azure Active Directory to put in there. So that's a little bit outside the scope of what I was going to talk about today. But if you want to talk about that after, I can show you how we would do that. So anyways, to get at SignalR, all you need is a connection string. Same thing as you would use in, like you're talking to Azure SQL. Pop that into your application and you get at it. To connect to Azure SignalR, let's close everything here. And let's see, close all tabs. It's fairly straightforward. It's going to be in our program.cs. I have helpfully added a comment so you don't have to watch me type. What we're doing is there's an Azure SignalR NuGet package that we want to add. And it's during the building of everything, and injecting the services into the middleware, where we're saying, you know what, require sticky mode, and then here's our connection string to use. Then later down the line, what we also have to do is tell SignalR, or Azure SignalR, which SignalR hub to use. When you're using the built-in ASP.NET SignalR, there's a built-in hub, an Azure SignalR, or a SignalR hub. When we're using Azure SignalR, we have to provide our own hub. What does that look like? It's pretty straightforward. This is all there is to it. We just have we inherit from a hub, and we just want to broadcast. And here, this echo, that's just for, don't necessarily have to have that here, but really we're just broadcasting and say, you know what, send it all async. We could implement more had we wanted to do specific clients and such, but really broadcast, send it out. The clients class has a bunch of different, we can do groups and so on, but for our purposes, we're just kind of sending everything against the wall for now, but you have to implement your own hub for what you want to do. And there's lots of examples online on how to do that. And so anyways, map it up, and then away we go. And of course, put in a connection string within there. And that's it. Once we do that, we're no longer using the built-in ASP.NET Core SignalR, we're using Azure SignalR. Minimal code changes. Yes, question? This is for Blazor specifically. Yeah. To be honest, the changes for ASP.NET SignalR would be, you're still going to be creating a hub, and you wouldn't be doing sticky mode, or you would be doing, I don't think you'd be doing sticky mode at that point. Don't quote me on that. I do have an example that I can put in the GitHub repo that I'll be showing. So, but when we get to the functions portion, you'll see how to do regular SignalR. Oh, question in the back. So the question was, what's the difference between ASP.NET SignalR and Azure SignalR? Azure SignalR is just bigger. It's meant for enterprise deployments and having a lot more traffic directed to it. So that's really the only difference to it. All righty. All right, so let's jump into the real-time order tracking and Azure Functions a little bit. So the way this is set up, we have the SignalR hub kind of sitting in the middle. Then we have Azure Functions as our broker. It's going to handle registration from our client and also pushing updates of the order, Azure Functions itself. So what is Azure Functions? So Azure Functions is the serverless offering from Azure, meaning serverless, it goes away, the server disappears and you're not getting charged when it's not running. Normally when it's demoed as building up quick web APIs. But it does a whole lot more. I, of course, am just demoing the quick web APIs, but I do want to talk about that it functions starts based off of triggers. And that's what the little lightning bolt is supposed to get across, that it's starting based off of triggers. And the triggers are other external web services or other external services. Now, whether that's Azure Storage, like something getting put into a queue or getting put into a table service, or it's table storage, or even like something getting changed in Azure Cosmos DB, something external changes or externally happens to functions, functions then starts. And it's just a little function. You have to think of a function just being one piece of code doing one little thing. So it's a little bit different mindset, even from like a minimal API. And then it has bindings. And the bindings are actually what's really neat about it. So the bindings set up to having, you can think of bindings both as input parameters and also output parameters. So let's say we did have an Azure function that kicked off from a blob being put into a new blob container. And then we had a binding also, an output binding, that wrote to an Azure storage queue. So we get all the information about the blob being written just from the binding of the input coming in. And so like we would get the blob itself and all its metadata. we would actually get a connection to the storage queue, so we can write to it just by doing return. And so essentially, we're not having to new up anything or know all the classes or anything like that. It just works for us. And we can get things from like Cosmos DB, and we can pass in a Cosmos version of SQL and filter down the rows that come into our function. So functions, like, it has these input parameters that do all the work for us, and we let the functions runtime take care of it for us. So it gives us, it's like that one step above platform as a service, this functions as a service, which does a lot of work for us that we don't have to really manage in our code. So this is what the web app now is going to start to look like. We have SignalR and a broker running. And so we have an external application, which happens to be our browser, register with the broker. So it's saying, you know what, I want to be alerted of anything happening. I want to know when the pizza gets out for delivery. And then anytime that a function gets hit, our Azure function says, you know what, we had an update. It's going to send that information back to the pizza server, or the Pizza Blazer server application. So let's take a look at what this happens to look like in the code. First off, by loading up the Azure Function app. All right, there's not a whole lot of code here. All I'm doing in the constructor is getting a configuration client in, and that configuration client gets me my Azure SignalR connection string being put in. And then next up comes the fun stuff. First off is the negotiate function. And what this negotiate function does is that I am essentially saying, hey, SignalR, I'm going to connect to you. And it's part of this, the SignalR connection info. This right here is an input parameter, but it's also the output parameter. So all I'm doing is saying, you know what, whoever is calling this negotiate function, the input parameter is this hub name of delivery info. And all I'm doing is saying return it. Whoever calls this is getting the SignalR connection info with a hub name of delivery info. Functions takes care of knowing all this up for me. I don't really know much of what's going on here other than the hub name. This is being kicked off. This function is being kicked off by an HTTP trigger, post, and that's it. The route happens to be negotiate. So it's going to be function name, order tracking function, or actually just /negotiate. That's what it's going to be. Actually, API /negotiate. Just that's the function's nomenclature of naming things. So that's it. Another neat thing that we're doing is building up Swagger tooling on top of this. So you don't have to do this stuff, but person on my team, Justin, put this in. So API tooling, open API operations. So just by doing these two decorators on top, we're able to put in a Swagger to it so we can test it out as well. It used to be, but now all you're doing when you new up a function package, you can say, I want Swagger or OpenAI as part of my functions. So on the latest versions, API. It's we have to rename things now. Yeah, OpenAPI. Although pretty soon it might be OpenAI and it just knows what you're thinking. So, but yeah. And down here, the next one is track order. So again, we're giving it a name, function name, and this function name is what it's going to come out as. /track order. Bunch of open API operations, again, just kind of building up the Swagger tooling. And then also getting kicked off with a HTTP trigger, another post, and this time it's coming in with a order ID /status ID. So it's kind of setting up the route the same as you would do in a ASP.NET API. And then what's nice is you can see this order ID. I'm binding it to that order ID that's coming in. So it's kind of this declarative setup. Finally, my output, again, signal R, typing in the hub name and the messages I want to send out. And since this async collector, I could send out more, but I'm only doing one. And so then it's just a bunch of my logic here. And I do right here, I actually do end it. Default, it's on its way. We never actually get it delivered. And I'm just adding async requests to it. So I could add a bunch of other ones and kind of just get it streamed down. But it's target message, new message, and then adding the message to it. So it is assuming, because it's my function, that I know like I'm sending a new message and I have to know that, or my new message is the target, and I have to know that which hub I'm adding it to. But that's stuff that you would have to know. It's like knowing your connection string. I'm going to use my tracking URL from the configuration value, which is my full URL to the Azure functions, negotiate, or just to the Azure function API. It knows to call negotiate, and just saying, hey, automatically reconnect, build it. And then anytime something comes in with a new message, just change up whatever you happen to be displaying on the UI. So the trick is using the hub connection builder, this is on the client, and then listen for new message. Normal ASP.NET signal R on the client, and then on the function using this signal R and this signal R connection info. Oh, what's changing? So what's coming in on the UI state right here, the new message comes in, and then there's this order status URL right here that's part of a tracking object, and then this is my tracking razor, and up here it's just an image source that's changing. So I'm changing the property that maps to the image source on the web page. New message comes in. This is the URL for the image. This is the name that gets displayed. Right here is what causes the page to update. So the question is the return from the function. What the return from the function does is updates this hub connection tracking message. So the function right here is returning, and it's saying, you know what? New message. Anybody who's listening to new message, invoke right here, because you're listening to a new message. So this, oh yeah. So this OK object result over here, this just gets when it's done. So after it loops through and puts everything into this async collection, yeah, it's done and you can stop listening. So it's just saying, you know what, I'm done for now. Yeah. Yeah, so that's just an indicator to saying, yeah, we're through. That answer your question? Okay, back to the other page. The funky not equal, right here? Line 20, right here, all right. The question is the funky not equal. That is from, yeah, no, it's a special keyboard that they hand out the first day here. That comes from Cascadia Code font. So it's a ligature. And Cascadia Code should be built in with the latest versions of Visual Studio. Otherwise, I believe it's an open source font that you can install. Yeah, so if I go back to Cascadia Mono, just the exclamation point with the equals. So, yeah, the lambdas look not as cool. So, yeah, it's just, I don't know, a way to look cool. So I take any advantage I can get with that. Nice. All right. Cool. So any other questions with Signal R and functions? Yeah, it's Cascadia Code. Should be built in with Visual Studio. And if it isn't, just Bing it, and it should bring it up. It should be on GitHub as an open source font. All right. All right, so this is actually one of my favorite spots is configuration values and secrets in one spot. I only have 2 portions here. I'm getting ahead of myself. All right, so here we have Azure App Configuration and Azure Key Vault. And so Azure App Configuration is a fancy spot to store your app settings in, but it gives you more. And Key Vault is a way to store your secrets, right? So it's your secrets that are, it hits like the Department of Defense, values, like, so it's like unbreakable, so everything's unbreakable, but just in, you can have trust in it, right? And what's nice about Key Vault is that you can version things. So if something happens, like your secret does happen to leak some other way, you can go to Key Vault, and then you can swap it over and version it. And then somebody who's accessing it, like you as developers are accessing it, you access Key Vault via URL, you don't care that the secret's changed. It just works. You're still grabbing the same thing coming down. Ideally, though, it wouldn't be coming down to you at all, and we'll get to that. App config, though, which has, let's say, our CDN URL to it, something that's not really secret at all, it's just a configuration value. We can put stuff into there like that. App config can also reference Key Vault and get at things there too, right? And then when we access everything in our code, it's just the same way as we would pull it back from app settings. So quickly, let's take a peek at that before we show off managed identity. So Key Vault is right here. And I can go in, look at my secrets, and I have various connection strings already popped in here. And it shows the current version with a hash. And I can see the secret value, copy it out, and go on. Now, let's say something got broken. So the first part of it is that when I want to get at this value, I normally would just get at it via the highlighted portion. KV-signal-r-connection-string. I wouldn't use this back portion to it unless I wanted to get at that specific version of it. However, if I did leak it, I could say, you know what, that's not enabled any longer, and just kind of shuts it off from the world. So do I have something in here that I can... functions, I won't turn functions on. So let's do a new version. And I will say create, please fix the errors on the page. Oh, secret value. This is not working. Create. And so now we have a new version, but the old version's still enabled. And so what I'll do is just set that to no, apply it. And now, nobody could get at this old version. The new version's only there. And then when somebody's accessing it, they should never, the new version will just come back automatically. But the new version, you could still look at it in your application, right? And it still could leak. So we'll talk about that, how we could fix that in just a sec. But anyways, there it is. That's how you would do it. Ideally, you have an automated process to do it for you, so you're not actually clicking within the portal, but that's the general process that you would take. We could go into app configuration then. App configuration then has a configuration explorer. And this is what is nice about that. I can have regular keys. So this one just says Azure Signal R enabled, true, just pulling back a key. Or I have one here that is Azure Signal R connection string. And what I'm doing here is I'm pointing it at a key vault and then picking a secret from the key vault to pull back. So that's nice. And the reason that's nice is that I can now access everything from Azure App Config rather than accessing some values from Key Vault and some values from Key Vault App Config. Just go to App Config to get everything. All right, and so then when I go, how I do that, where I would enable that from, is, let's look at, I think, Menu API has a good example. Right here. So there's two Azure packages enabled. There's an Azure App or Azure SDKs. There's an Azure App Config and an Azure Key Vault SDK. So when I put this in here, so it's just configuration, add Azure App Configuration, and then passing in things like just the app config URL. And then after that, if I want to also make sure that I'm getting at Key Vault, I can just do configure Key Vault and then get at that. What I want to drive home here then is this, default Azure credential. So now what I'm saying is I want to use whoever I'm logged into Visual Studio as to get at Key Vault. I'm not going to use any connection strings anymore. I can just wipe out my connection strings altogether and get at things. And then I can still use this code the same as usual. Builder.configuration MenuDB to get at my values. So let's see, this is here. So I am going to go through my MenuDB, secrets.json, manage, and I am going to delete my MenuDB one. So this is now gone from my app settings, from my secret.json. And then let me make sure so this is my key vault, my app config URL, still there, so now I know how to grab it. I'll stop everything from running. Let's just start up the menu API so it runs a little bit faster. And so because I'm logged in as me to Visual Studio, default Azure credential should pull that back. I do have an app config URL, great. So I'm logged into app config. I can get anything from Azure app config I want. Now I'm going to log into Key Vault, essentially, or configuring Azure App Config to log into Key Vault for me. Great. And then I'll continue on. And then right here, no, let's just, don't get an error when I go through and add my SQL Server to it. Super impressed over there. That is wonderful. So over here, get the pizzas, try it out, execute it, and there I go. I get them all logged in because I have access to it personally. And the way I get access to it is going through access control, role assignments. And so this access control is on the app configuration. Here I am. I have app configuration data reader to it. And I also have the same corresponding on Key Vault. So I have to have both app configuration and also on app reader. 1 second, I'll get there. And then the next one is this user assigned managed identity. This is what I'm going to use to assign to different Azure services. So this managed identity is like me. It's like a user. It's like you would be in Active Directory, but it's for Azure services. And so then I can say, you know what, whoever I put this managed identity to, it also now has app configuration data reader values. So it can then use this default Azure credential to access Key Vault or access app config. And I don't have to change any code locally for me. I can just deploy up knowing that default Azure credential is going to access everything I want. And that's done through, let's open up the app service. 1 sec. Menu API. And if I look at identity, and so the user assigned one is just right here. That's the managed identity that I signed up. So whoever I have assigned here, it has all the roles for this managed identity. Okay, question? All right, I answered it, good. This is Active Directory rights. So when I create it, I need like administrator Active Directory rights as me. Yeah, so like if you don't have it, yeah. So that's part of the provisioning, Azure provisioning process that whoever provisions your resources would have to have. So if it's you or the IT admin, you know, that's something that you'll have to work out in the backroom deal to it. All right. That's part of the password list. Yep, that's exactly it. And that works more and more. So not all Azure services have that quite yet. So I'm trying to think of one that doesn't have it yet. Redis. I don't think Redis Cache has it yet. If I said it before, I was mistaken. But it's coming. They're all coming. And so that's the idea, that they're all going to be here very soon. So yeah, it's the make your services things in Azure Directory. Then you can apply roles to those things. And you don't have to worry about connection strings any longer. Question? So, yeah, so the question was creating a managed identity directly within the app services configuration. So there's two types of managed identities. There's a user-created one, which I just showed, and then there's a system one. So the system one, I think, is the one that you're alluding to. Okay, so that then is news to me. But the downside to a system one, and they're both perfectly valid, and that's the one I usually use as a system one, but system one is for the service that you created it for. The user one, you can apply it to multiple services at once. And then if you know a bunch of different services like my microservices, are going to have the same rules based to it. They all have to read key vault and they all have to read app config. Then I can just apply it to multiples at once. So it's kind of how you want to manage your stuff. Both perfectly valid, 100%. All right, so this is what, I'm starting to hurry up a little bit because I want to talk about Azure Dev CLI. But this is what we're looking at right now. Key vault, app config is protecting everything here to so they can get at various services. All right, we took a look at that. Now, Azure Developer CLI, that's how I deployed everything. And it's known as AZD. You'll hear AZD and Azure Developer CLI interchanged. And it's a way to both provision your resources in Azure and also deploy your code in Azure, all from the command line. And it's actually super cool in that you can deploy it from the command line. You can delete it from the command line. Both you can provision it. You could just provision it. You can obviously you can't deploy unless it's provisioned. It's really neat. And so first thing I'm going to do is open up a new PowerShell prompt. Let's see GitHub. I'm going to start provisioning something first, and then we'll come back and talk about it. All right, so it's going to be AZD env new, and we'll do VS live. And then AZD provision. So what I'm telling it now is to take all the bicep files I have and start creating something for me. We'll come back, assuming I don't get any errors. Oh, I have to tell it what I wanted to do. Okay. East US. Do it. Do it. Okay, good. So let's open it up. So what AZD uses, is it asking for something? Oh, infrastructure, SQL admin login. Let's do SQL admin. Password, we'll use at home or using the same password as before. All right, so let's go into here. Oh, not that we want. Secrets.json. MenuDB. Control C. Yes, we'll save it. Password. There. All right, now we're creating the resources. Okay, so what happens with Azure CLI is that it uses, it's very, I guess, declaratively based as well, in that it uses a couple different things. It uses, when it starts deploying things like I'm doing now, it uses everything that's in an infra folder. And this infra folder has a bunch of bicep files. And these bicep files are super neat. How many people are familiar with bicep here? Okay, a couple. In that, they are the newer version of Azure resource templates, and they're meant for provisioning. And it's nice in that things can come in, parameters. You can bring parameters in, and you can have things like if statements and so on. And so let's go out to like Azure SQL. So every one of these on the left-hand side are meant for me to create a new Azure storage or Azure service. And so that's what I'm doing right here. I'm creating a new SQL server, passing in the login and password to it. And then I'm passing in the databases, then creating the databases on the server. And I'm using a recent, right here, the reason why the names were really weird before is because I'm doing a resource token to it, creating the resource token based off of a unique string based off the subscription ID. That way I can just do AZD provision and not worry about having name collisions. So, but yeah. So it's a way for me to go through and have all these put together. And what's nice, it will figure out any dependencies for me. So like if anything depended on Azure SQL, it's going to figure that out. and it's going to put it all together and do it for me. And app service even goes all the way down, and I can set app settings within the app service and so on. Cool. Now, one of the things I do want to show off is there are various tags in here. So when I'm creating like the app service, I'm passing in the tags, and I'm also creating another tag called AZD service name. So when I look at that, I can have two different things. Whirlwind test. AZD environment name, Whirlwind test, and AZD service name, checkout API. And so what happens if I do an AZD? Are we good? No, we're still deploying. So when I entered VS Live for my environment name, that's going to become the new AZD env name. Cool. And there's going to be everything that I have in this resource group has that same environment name applied to it. So I can actually say, you know what? AZD down, and it's going to delete everything for me. So it's just that one command, and it goes through and it knows to delete everything for me by doing that AZD down. And this other right here, AZD service name, that's actually really neat as well. So that's what's happening when I do this tag right here. I'm doing AZD service name front end. I have one for each of the menus as well. And what I'm doing with that in an Azure.yaml file is I'm saying, like this tracker function, I'm saying, you know what? Let's deploy whatever is here, PizzaConf delivery tracker. It's going to be C#. Deploy it to it's going to be an Azure function, and look for the tracker function tag of what we deployed. So it takes care of like a whole DevOps scenario all locally for me, which is nice. So then when if that got done, I could just do AZD deploy, and it would push everything out, and it would work for me. So, and it would do, everything would work. If I would do AZD up, it does the provision and deploy all at once. Or I could break it up by AZD provision, AZD deploy. I can even create a GitHub Actions profile with it too. Check that in, and then whenever I push to certain branches or whatnot, I can then run this as well. So if yep. The question is, could the same thing be done with PowerShell? And the answer is yes. So here you'd be using the Azure CLI to do the deployment and everything else. Azure Developer CLI uses the Azure CLI, I believe, underneath the hood. I would prefer the Developer CLI, as it's a little bit easier to use for this purpose. It's abstracted up a level. Yep. Because the AZD is built into both Azure DevOps and GitHub Actions. So, cool. That is all I had. We hit it, hour and a half, or hour 75 minutes. So, thank you very much, everybody. I appreciate it. And yeah, any questions, let me know. Let me put my information back up. Matt.sokup. And, oh gosh, right here. Actually, go here. It'll redirect to a GitHub repo, which will have everything that you need to know. So thank you very much.